Okay, so we are starting lecture number 3 of 10. Alright, so we're still pretty close to the beginning, but we're getting there. This is the last part of naming that we're going over. So you've done simple ionic, covalent, polyatomic, and now acid and bases. Bases is actually very simple. Acids, this is not going to be probably anybody's favorite thing to do because they're not fun, I can tell you that. I put this meme on here to specifically show you that I am not saying that this is easy and that you will have to work hard to make sure that you do well on these, especially obviously for the tests. For this 9 weeks, they'll be on both tests just because that's the way this information works, is we just keep building on top of what we already know. So really, naming acids is going to be on every test until the end of the year. So maybe not every quiz, but every test, definitely. So if you are someone who has been really good at naming, then this probably isn't going to challenge you a ton. There's some memorization that has to go on, but you'll be okay. If you've tried really hard on naming and you've found this to be a little bit of a struggle, then you're going to have to put in some extra time studying this because it's not going to be easy. If you are someone who has just completely, sorry, there's a piece of hair on this paper. It's really bothering me. We're good now. If you are someone who just has decided to not put forth the effort to learn how to name, this is only going to make matters worse. And I 100% promise you, I have experience in watching students go through the second semester of chemistry. This will be one of your enormous downfalls if you don't pay attention to it. I have students who go the entire second semester without ever learning this, and it's almost impossible to do well without knowing this information because acids are really important in chemistry and we name them a lot. Okay, so your EQ says, how do you use polyatomic ion suffixes to name acids containing those polyatomic ions? All right, so essentially what we're going to do is we're going to use what we know about the 3 suffixes we've talked about so far. So ide, I-D-E, ite, I-T-E, and ate, A-T-E. How we use those endings to name acids. All right, but before we do that, we should probably talk about what acids and bases are. This should be a little bit of a review from physical science, but as I always say, I have to start off as thinking that you know absolutely nothing, because some of you don't. It's not your fault, but some of you come in with no prior knowledge, so I always start at the beginning. So as it says, for now, it is good enough to know, whoa, got a little excited there. Okay, it is good enough to know that an acid is a compound that contains one or more, I'm going to get a highlighter out, hopefully you can see it, one or more hydrogen. Okay, hydrogen being the key word there as the positive ion. Okay, and as I have said many times over in class, I'm unfortunately going to have to keep saying it. Hydrogen, this could be important for you to write down. Hydrogen is stupid. Okay. Hydrogen causes so many problems because it has its own set of rules. It only needs one more electron, but it only needs to drop one. It only has room for 2. It can do so many different things because of the fact that it only needs 2 hydrogens to be stable, but it only needs to lose 1 to form, a +1 ion. So I'm actually going to give you a second to write this down, and we'll just go over, I guess, these 2 examples pretty quickly, but we're going to go ahead and pause it real quick, give you a chance to write that, and then we'll hop back in and I'll keep talking about this, and then we're going to fill out this, this chart that you should have copied during the do now. All right, so leave that up for a second. You guys can pause it, write it, and then I'll talk about it. All right, let's talk about why hydrogen is stupid. So an acid. All right, up until now, if you've seen H2S, we've treated that like a covalent compound, right? We would maybe call this like dihydrogen monosulfide. In all reality, it's not that that's an incorrect way to name it, but it's really not the most accepted way to name this. All right, because believe it or not, when we're talking about acids, we don't even treat this like a covalent compound. We treat it like an ionic compound. We treat this like this, that we know hydrogen's a +1, and that sulfur's a -2, and that we cross, sorry, I drew that wrong, that we cross those charges over. All right, so acids, okay, as it says here, and you can make a note if you want to, acids are, hopefully you can see that, ionic, okay? We treat them like ionic compounds, even though I understand this is a nonmetal and this is a nonmetal. Because in acids, we treat this as a cation, okay, because it's got a positive charge. Acids really follow ionic naming rules, or ionic principles, not covalent principles, okay? Bases are so much easier. A base, as it says here, is a compound containing the hydroxide ion, and for this year, none of you had to memorize the hydroxide ion. It's on your polyatomic chart, but hydroxide is OH with a -1. If you have a compound that contains that, it's a base. Okay, anything that ends in hydroxide is a base. There are plenty more bases that don't have hydroxide in them, but for our purposes for right now, those are the only ones you need to worry about. So if you have anything with OH as the negative ion, it's a base. Okay, anything with a hydrogen as its positive ion, it's an acid. Okay, so let's go ahead and fill in this chart. And I'm going to, I understand you can't see the whole thing. I'll just move it up as we go. Okay, so one note that you might want to make somewhere on your paper somewhere, anywhere. Said the word somewhere a lot. And anywhere in your notebook around this area, unless you could do it on the notes that we just wrote down, but it's something very important to remember, okay? And this is pretty, I don't think there's any exceptions that we're going to talk about, is that in every one of these, okay, in every one of these, I'm actually going to write this here. Let's write the anion ending, okay? Anion ending. Your anion, your negative ion, remember that's the only one we've ever changed to these three suffixes. So if you want to put somewhere else that the cation is always H with a +1 charge, hydrogen with a +1 charge, always, every time. All right, there are no exceptions that I can think of at this moment that we will come across where that's not the case. All right, so this is going to tell you your anion ending. The cation, there's no guessing. The cation in all of these is H with a +1 charge. Okay? So naming rules. If we are going to cross hydrogen, okay, the hydrogen ion, H+1, with an anion that ends in "ide," and remember, "ide," if you want to make a note somewhere around it, no oxygens attached, none, okay? If your anion ends in "ide," remember that's straight from the periodic table. No oxygens attached. Okay, simple, like we did before Christmas when I was still there. Okay, "ide," no oxygens attached. All right, so let's work through a couple of examples, and then we'll incorporate what all of this means as we do the examples. Okay, so let's say you are given H2S. All right, this is going to be, hold on. I think somebody's gonna walk in the room, so I'm gonna have to sit here and be quiet for a second. It's gonna be awkward for everyone in the room right now. I'm gonna wait. I'm gonna wait for it. Wait for it. Nope. Okay. If I just stop talking all of a sudden, it's because someone walked in the room. This is already really weird to sit in a room by yourself and talk to nobody. If someone walks in this room, I'm gonna have to pretend like I'm not doing this. Okay, so bear with me. So if I just stop talking, or if I go off and sound like I'm talking to someone else, I'm probably talking to someone else because I don't want them to know I'm recording. All right, so if I give you H2S, all right, so you know that this is hydrogen and sulfide, right? I-D-E, hydrogen and sulfide. Okay, we would probably name this dihydrogen monosulfide, hydrogen sulfide. Okay, there's a lot of different ways we can name it. The most proper way to name it is the way that we're going to learn right now. Okay? So here's what we need to add. We need to add the prefix hydro. All right, so this is going to be called hydro. And then it says the suffix "ic," but obviously you know with a prefix and a suffix, we need a base, right? We need a base word, not like a base like in chemistry, but a base word like in grammar. So the way that we decide the base word is the anion. Okay, in this case, that's sulfur or sulfide. So our base is going to be sulfur, and this is going to kind of be the problem, just like you had in when you were learning how to name it first, how you didn't know which letters to cut off of the end, you know, that if it was phosphide or phosphoride or, you know, sulfide or sulfuride. You're going to have that same problem, but you'll eventually learn them, so I'm not going to stress out, you know, don't stress out about that too much right now. So we've got our prefix is hydro, our base is the anion name, and then our suffix in this case is "ic," so hydro sulfuric acid. Okay, notice acid is there as well. So H2S is no longer called dihydrogen monosulfide or hydrogen sulfide. It is hydro sulfuric acid. Okay, so when it's just a single element as your anion, no oxygens attached, not polyatomic, hydro as your prefix, your base is your element, your anion element, and then "ic" acid. Okay, let's do another example. Let's say I were to give you, we're going to do a couple different ways to do this. So let's say I wanted you to make a compound out of hydrogen and nitrogen. All right, hydrogen and nitrogen. I'm going to zoom in a little. So I want you to make the compound and also give me the name. So let's make the compound first. So again, treat this like an ionic situation. Hydrogen's your cation, nitrogen's your anion. So the charge of hydrogen, hopefully this is no longer a thought process you have to go through. The charge of hydrogen is +1, right? That's what it's always been. When it forms a charge, it forms a +1. What's the charge of nitrogen when it forms a charge? And yes, I'm going to awkwardly wait and hope that you're all answering. What's the charge of nitrogen? Good job. It is nitrogen with a -3 charge. All right, so if we're going to make our compound, we know we cross over, right? So the 1 goes to the hydrogen. I'm sorry, the 1 goes to the nitrogen, the 3 goes to the hydrogen. So we've got H3N. So far, so good, hopefully. Now, if I want the name of this, all right, the name, just like we just talked about, prefix, root word, suffix. So our prefix is hydro. Sorry, that's a little difficult to read. Our root word in this case is nitrogen, but we're not going to use the whole word. It's just going to be NITR, okay? And then our suffix is "ic" acid, so hydronitric acid. is what that would be called, hydronitric acid. Hopefully so far so good. The last type of example, let's say I give you the name. So I'm going to ask you for the formula for bromic acid. All right, so if I give you the name hydrobromic acid, and I want the formula, okay, so how you would have to kind of work through this. And this is the part that gets a lot of people. So you immediately have to notice the hydro and the ic acid. Okay, hydro and ic acid. The second that you see hydro and ic acid together, you know, okay, that your anion ends in IDE. All right, so to do the simple part first, I guess, we know no matter what, our cation is H+1, right? So we know that we're crossing hydrogen with a +1 charge. And again, since we notice this is hydroic acid, our anion is just the ide anion. So bromide, right? We know it's bromine because of our root word, bromide. And what is bromide? Hopefully, I can say good job, and you all said it's just bromine, and then with its charge. And what charge does bromine form? Good, a -1. So now you're just going to cross over like we've been doing, right? And they're both 1s, so it doesn't really matter. They're going to cancel out, and you would get HBr is hydrobromic acid. Right, again, it's a little tricky. I understand it's kind of tricky to do the crossing over and uncrossing over and put together all these prefixes and suffixes, which is why thankfully this is a recording, so you can go back and watch this. You can YouTube it, go online, find help. Mr. Fier can help as well. But it's not easy. I'm telling you now, this is not easy stuff, okay? Next, so we took care of ide, right? We know our 3 suffixes for our ions, our anions, are ide, ite, and ate. So let's talk about ite. So we know ite have oxygens attached, right? So we're going to put oxygens attached. Well, you don't necessarily have to write this if you think you'll remember it, but you might want to, if you want to make some notes off to the side, these would be good ones. They have oxygens attached. But remember, ites are the ones with less oxygens. Okay? Remember, ates have 1 more than ites, so the ites are the ones with less oxygens. And notice we don't even have a prefix on this one. This is the only one that actually gets a prefix on the acid name. This one is just a suffix. All right, so we're going to do 3 very simple examples, kind of the same type of examples. So for this first one, let's say I give you H2SO3. Sorry, my Sharpie doesn't fill in very well. Please focus. That's better, I guess. Okay. So if I want the name of this, okay, how you're going to have to work through this. So immediately you see hydrogen. Why is that so blurry? I guess that's as far in as I can focus. So immediately you see the positive ion is hydrogen. So that should be your first indication that this is an acid. Okay, when you see that hydrogen's the positive ion, immediately an acid. Okay, so we know this needs to be named as an acid, not as just a regular, don't call this hydrogen sulfite. Okay, you have to name it as an acid. So we know acid naming rules apply. So then your next job, obviously, is to figure out the anion. That's the only way that you're going to know which one of these rows to follow. So we have to figure out SO3, right? And then we know this 2 was crossed over. So your job right now is to figure out what SO3 is with a -2 charge. For regular, you can look it up. Honors, this is one that you need to have memorized. So SO3, if we work backwards, we should figure out that is sulfite. Okay, I-T-E. So to name this as an acid, okay, acid naming rules tell us we're going to add a suffix, but remember, to add a suffix we need a root word. So our root word again comes from the element involved in our anion. So this is sulfur, so this is going to be called sulfur. We'll put sulfur as your root word, and then you add OUS, us acid, to the end. So H2SO3 is actually better known as sulfurous acid. Right, that's what you'd have to call this if you were naming it, sulfurous acid. Another example, let's say I want you to tell me the combination of hydrogen and NO2 with a -1 charge. So you could immediately tell me what's the charge of hydrogen. I hope everyone in the room said +1, because you should know that by now. All right, so I want the combination and the name. So the combination is pretty simple, right? It's a +1 and a -1. So you're just going to put them together. HNO2. No big deal. If I want the name, again, immediately, first thing you should notice, hydrogen's the cation. This is an acid, okay? Even if you wanted to, you could just already write hydrogen's the cation, write acid. It's going to be an acid. Your job is just to figure out which root word and suffix you need to add to your acid name. So again, your root word is going to come from the element involved in your polyatomic ion. So we know that's going to be nitrogen. And again, you'll get better at this, but the root word to use for nitrogen is NITR. And then we know this is nitrite. NO2 with a -1 charge is nitrite. I-T-E. I-T-E. So if this is hydrogen and nitrite, then we are going to call it nitrous acid. Nitrous acid would be the name of this. All right, to give you a similar, again, I'm just trying to follow the same types of examples as in the first box. So let's say I ask you for the formula for chlorous acid. All right, chlorous acid. So thoughts that should be going through your mind. You see acid, immediately you should know, oh, my cation is what? I don't want to move my hand because you're going to see it. But you see acid in the name. Your immediate thought is your cation, H+, right? H with a +1 charge. Next, some important things to look at. Us, O-U-S, should immediately tell you, well, if my suffix is OUS on my acid, then my anion ends in ite. Okay, so this is going to be hydrogen crossed over with chlorite. Okay, if regular, you can just look it up unless you've chosen to memorize them. Honors, remember, ite, chlorite. Well, then chlorine is really the one we are focusing on. So which word from this sentence helps you remember chlorite? Hopefully you are saying clam at the moment. So we know the word from this sentence tells us the 8 element, right? The 8 ion. So we know this would be ClO 1, 2, 3 consonants. And a charge of -1 because of the 1 vowel. Remember, this is 8. We need ite, right? Because this is chlorous acid, so we need ite. So how do we know what chlorite is based on chlorate? Hopefully you're all thinking or saying that it's 1 less oxygen. So chlorite is actually ClO2 with a -1 charge. That's the one you're going to use in our example. So you're crossing H+1 with ClO2 -1. Sorry, that minus got a little sketchy when I drew it. Okay, that's ClO2 with a -1 charge. Now you notice it's just 1 and 1, so just put them together. So chlorous acid is HClO2. That's the thought process you're going to have to go through in order to name these. This is not easy. Again, I'm going to say that after every row. This is not easy stuff. This is going to require a lot of practice. Okay? Last one. So the only suffix we have left to talk about is ate. We know in ates a couple things. Oxygens are definitely attached, right? So oxygens attached. And the other thing we know about our ate ions is of the two, of ite and ate, ate is the one with more oxygens. Okay? Just to clarify, again, to clarify the difference between ite and ate. Ites have no oxygens attached. Ites do, but of the two choices, they are the ones with less oxygens. And then of the two that have oxygen attached, ate is the one with more oxygens. And again, regular, you can always refer to your polyatomic ions chart. Honors, Nick the Camel. Okay, Nick the Camel is who is going to save you during this. Always go back and refer to Nick the Camel. So suffix, only a suffix, no prefix, and your suffix is actually ic, which can get a little confusing because if you notice, the suffix on the first one was ic and the suffix on the third one is ic. So the difference is obviously the hydro attached to the, the first one. So in these ones, you're only adding the suffix, you're only adding ic. So I'm sure you've heard of like sulfuric acid. Okay, that would be this. Hydrosulfuric acid would be the one with the ide ion. Sulfuric acid would be the one with the ate ion. All right, and surprisingly, that's the example we're going to do. So let's say I give you the formula H2SO4, and I want the name. All right, so a couple of things. Immediately, again, and I probably sound like a broken record, immediately you see hydrogen as your cation, you should already know acid. Okay, this is going to be an acid. It's the first thing that needs to cross your mind. You see hydrogen as your cation, name this as an acid. Next, you need to figure out the base word. Well, again, look at the element involved in your polyatomic ion. It's sulfur. So you know your base word is sulfur. Now you just need to decide what SO4 is. Okay, is it sulfide, sulfite, or sulfate? Now, just throwing it out there, we're doing it in this row, so it shouldn't be hard to figure out this way. But when you're given an entire worksheet on these, you're going to have to be able to figure these out on your own. So, again, you immediately see oxygens attached, so that eliminates the fact that it is ide. Okay, ides don't have any oxygen, so ide is crossed off the list. You know it's not ide. So now it comes down to ite and ate. Regular, look it up on the chart. Okay, figure out which one SO4 is. Honors, use Nick the Camel. You know the word from Nick the Camel that's going to help you is supper. Right, and supper is going to tell us the ate ion, which would be SO1234 with a -2 charge. So we know this is sulfate. As long as that matches that, then we're good. SO4, SO4. So this must be sulfate, which means we're going to name this sulfuric acid, right? Because when your ion ends in ate, your acid ends in ic. Okay, so H2SO4, sulfuric acid. All right, let's say I asked you to combine hydrogen and NO3 with a -1 charge. First thing, immediately, well, it's hydrogen, it's got to be a +1 charge, right? To combine these to make a compound, not that difficult. 1 and 1, you should know, just put them together. HNO3. Compound simple, done. If I want the name of this though, again, it takes a couple more steps. You see hydrogen, obviously, what's the first thing you should think of when you see hydrogen as the cation? Answer. I want you to answer. Okay, hopefully you said you automatically know that it's an acid. No questions asked. It's an acid. It starts with hydrogen, it's an acid. Next thing you need to figure out is your base, from here, is your base word and your suffix. So So your base obviously is nitrogen, so we're going to put our NITR. And now you need to figure out your suffix. If it's NO3, O, first off, oxygens attached, again, should tell you it's not ide. There's no oxygens attached, it's definitely not ide. So then you have 8 and ite as your options. So this is either nitrous acid, or nitric acid. So you just need to decide, is this nitrate or nitrite? So either using the chart or the sentence. Okay, we know from the sentence we would use the word Nic. And we know Nic is, since it's directly from the sentence, is going to help us remember nitrate. So we know it's NO123, right? 3 consonants and a charge of -1. So if this matches that, then we know it's nitrate. This matches that, so we know this is hydrogen and nitrate. So when it's 8, we just add the suffix ic. Okay, so nitric acid. And then our last one, let's say I ask you for chloric acid, and I want the formula for it. All right, so first thing, you see acid, what should you think? Oh, I'm gonna wait. Someone should answer. If you see acid, what should you immediately know about your formula? Miss Vero, we should know that our positive ion is hydrogen. You guys are so smart, I can't even handle it right now. Yes, you are correct. Your positive should be hydrogen, and it should have a charge of +1. All right, positive ion taken care of. Now you need to work backwards from this information. So you immediately see chlor, right? So that should tell you, well, I know chlorine's involved in my anion. And now you just need to decide ic. What is ic telling you? Well, ic is telling you that you need to be using chlorate in this formula. So now your only job is to figure out what chlorate is. And we actually did that up here, right? When we were trying to decide this one, we were trying to decide chlorous acid, and I'm going to need to highlight this just so they all look the same. We were trying to decide chlorous acid. Well, we used clam. We decided this was chlorate, which meant this had to be chlorite. So you already did that. This chlorate right here. All right? So we know chlorate is ClO3 with a -1 charge. So now just cross them over, and again, they're 1 and 1. Not too difficult. Put them together. So chloric acid is HClO3. All right. This is a lot. I completely understand this is a lot to take in. I'm going to give you hopefully some helpful tips to help you as a test slowly approaches you. A couple of things, okay, a couple of tips that I would be giving you if I were there, especially for honors. Okay, as you figure out polyatomic ions using this sentence, I'm going to tell you to make a list of polyatomic ions during the test. Okay, during the test. Make a list of polyatomic ions. Let me zoom out a little. During your test. Okay, because you don't want to have to figure out, 4 times on a test that nitrate is NO3. Once you do it once, you see like, oh, I need to figure out what nitrate is. Well, I know Nic is going to help me remember nitrate. So I know nitrate equals, well, I know it's N. It's got 1, 2, 3 consonants, so it's NO3, and it's got a -1 charge. If you don't want to have to do that every time you encounter nitrate. So once you figure it out once, start making a list on the side of your test somewhere, anywhere, that you know nitrate is NO3 with a -1. Okay? You could also throw in there, if you wanted to, that, well, once you figure out nitrate, you know nitrite is what? I want you to answer. Nitrite is NO2. Very good. And what charge does it have? Same charge, right? The charge isn't gonna change. So nitrate, NO3, nitrate, NO2. As you go through a test, make a continuous list of polyatomic ions so that you're not constantly having to look back at the words in the sentence to figure them out. Okay, do that. I personally find that to be the most efficient way to take a test. Okay? Someone's coming. You're good. Come on in.
Hey, each energy level of an atom has a maximum number of inner. I never even talked about the inner. I talked about the outer. Maximum
Yeah,
of,
that can be different.
I know, right?
Each inner energy level of an atom has a maximum. Oh, it's just electrons, right? Because protons and neutrons are in the nucleus.
Yeah, the nucleus.
So it's just
So it's
electrons.
just
I was
electrons.
thinking of like an actual number, like.
Yeah, that's what I was thinking
So
too.
it's just
but-
electrons
yeah,
are in the
okay.
in energy levels.
All right.
That's all it's going for. Is that your 9 weeks
Yeah,
exam?
Yeah. Gotcha.
Told you. If anyone comes in this room, I have to pretend like I'm not recording. So you're all laughing. It's fine. You should laugh at me, but I feel bad. I don't want to make people feel bad they're interrupting. So we got this. All right. So back to my tips. Make a list of polyatomic ions every time you take any kind of assessment so that you're not constantly having to figure them out. Okay? My suggestion also is when you take a test or even the quiz, because guess what? On the quiz, you don't get your acid chart. Okay? You don't get to use that. That's something that needs to be up in your brain. All right, so do what's called, well, I call it cramming and regurgitating. That sounds absolutely disgusting, but that's what it is. So in your head before a quiz or a test, just, sit there and think, okay, hydro and ick is ide. Us is ite, ate is ick. Just do that, and then as soon as you get your quiz or your test, write them down, right? We know hydro, ick, acid equals hydrogen plus an ide ion, right? And then we know, well, root word us, acid, well, that equals hydrogen plus an ite ion. And then we know if it's something ick, acid, that equals hydrogen plus an ate ion. Right, these are test strategies that you need to get used to, especially in chemistry. These will help you overall, but especially in chemistry. All right, to not have to think this over every single time you come across it. Write some of this stuff down on your test so that you have it in front of you. Then you're not wasting so much time trying to go through this process over and over and over and over and over. All right, so those are just some things that I can do to maybe help. I hope it's helpful. Definitely go see Mr. Fierro if you have any questions on any of this. I'm going to make sure that I tell him right around this time that hopefully they can switch days and he can come in and help you with this. If the substitute is fair game to help you, that would be great too, but if not, no worries. Mr. Fierro is there to help as well. Watch this again if you're confused. Hopefully, a light bulb will go off, but I am telling you now, if you do not memorize this stuff, okay, if you don't memorize this, it is going to be a crash and burn for you in chemistry, okay? It's not going to end well because you will need this information until June. This will be on every test and your EOC, okay? It's going to be there. If you don't learn this is one of the #1 reasons why people's grades drop in chemistry, because they refuse to memorize this, they refuse to understand this. Please do it. If my video doesn't help, go on YouTube. Find someone else who's teaching you how to name acids. Go on Google, I don't know, do something. You have to make sure that you find some way that you understand this, because it's not going away, okay? Please understand it's not going away. Okay, watch this over again if you need to. Go see Mr. Fierro if you need help. You are definitely going to get some practice on this. You're going to find the practice is very repetitive because there's only so many acids I can ask about. Okay, so if anything, start memorizing if you think you're not going to remember the rules for how to do this, but hopefully you can. Okay, miss you guys, and hopefully you're doing well without me, and don't worry, I will be back after spring break, okay? I will see you all later. Good luck.